Atoms and Molecules Part 1 in this chapter. Topics to be covered: history, laws of chemical combination, what are atoms, what is a molecule, writing chemical formulae, molecular mass and mole concept. Maharshi Kanad said, "If we go on dividing matter, also called padarth, a time will come when we shall come across the smallest particle called parmanu." Philosopher Pakuta Katayama said, "Particles normally exist in a combined form." Democritus and Leucippus called these parmanu as atoms, so it is concluded that all matter is made up of small particles called atoms. Different kinds of atoms and molecules have different properties, due to which different kinds of matter show variable properties. When substances react, they follow certain laws of chemical combinations. There are 5 laws of chemical combinations, out of which we will be studying only 3 laws in Class 9. They are law of conservation of mass, law of constant proportions, and law of multiple proportions. Law of conservation of mass. This law is given by Antoine L. Lavoisier in 1774. This law explains in every chemical reaction, total mass before and after the reaction remains constant. It states that mass can neither be created nor destroyed. Activity 3.1 from your NCERT book is a proof of law of conservation of mass. For materials, we need sodium sulfate solution, barium chloride solution, measuring cylinder, test tube, thread, conical flask, stopper and weighing balance. Procedure of this experiment is as follows. Prepare 5% of barium chloride and sodium sulfate solution each. Take 20 milliliters of barium chloride in a conical flask. Take sodium sulfate solution in a test tube. Hang the test tube in mouth of flask with the help of thread. Close the flask with the cork. Weigh the flask along with its contents carefully. Tilt the flask so that 2 solution get mixed. Weigh the flask again and write the observations. Observations. A white PPT is formed when 2 solutions mixed. The mass after and before mixing remains same. Inference. Mass remains constant in a chemical reaction, hence it supports law of conservation of mass. Now I will show you the laboratory demonstration of activity 3.1. It is filmed by Amrita Olabs. For such informative resources, search Amrita Olabs and explore the experiential learning of scientific concepts.
Our aim here is to verify the law of conservation of mass during a chemical reaction. Materials required: sodium sulfate solution, barium chloride solution, measuring cylinders, 10 ml test tube, thread, 250 ml conical flask, cork, and an electronic balance. Procedure: take the beaker containing sodium sulfate solution. Pour 5 ml of sodium sulfate solution into the measuring cylinder. Transfer it into a 250 ml conical flask. Now, take the beaker containing barium chloride solution. Pour 5 ml of barium chloride solution into a measuring jar. Transfer it into a 10 ml test tube. Take a thread. Tie the test tube using the thread. Hang the test tube in the conical flask carefully so that the solutions do not mix with each other. Take a cork and put the cork on the mouth of the flask so that the thread holding the test tube is held firmly in place. Take the conical flask and carefully weigh the flask on an electronic balance with all the contents, ensuring that the solutions do not mix, and note the reading. Take the flask from the balance, tilt it and swirl the flask so that the barium chloride solution in the test tube spills and mixes with sodium sulfate solution in the flask and forms a white-colored precipitate of barium sulfate, BaSO4, and an aqueous solution of sodium chloride, NaCl. Wait for 10 minutes to complete the reaction. Take the flask and weigh the contents of the flask again and note down the reading. It will be observed that the total mass of the reactants is equal to the total mass of the products. Hence, the law of conservation of mass is verified. Precautions: when setting up the apparatus and while taking the first reading of the total mass of apparatus and reactants, care must be taken that the barium chloride solution in the test tube does not spill and mix with the sodium sulfate solution in the conical flask. To start the chemical reaction, tilt and swirl the flask well so that the barium chloride solution in the test tube spills and mixes with sodium sulfate solution in the flask.
I hope you have understood. Law of conservation of mass. Now the next is law of constant proportions. This law is given by Antoine L. Lavoisier and J. Proust. This law deals with the chemical composition of a substance. It states that elements are always present in definite proportions by mass in a chemical substance. In order to understand this law, I have taken an example. Water. It is a crucial part of our life. Have you imagined how water look like when we see at atomic level? Yes, water is composed of hydrogen and oxygen atoms, but are all kinds of water, which I mean seawater or freshwater or water from pond, lakes, rivers, glacier, underground, ocean, are all having the same hydrogen and oxygen. Yes, they are. And that's the beauty of this law. Water has 2 atoms of hydrogen and 1 atom of oxygen, and they are chemically combined to each other, as Pacuda Katiana said, if you remember. This law centralized around the atomic mass of the atoms. Hydrogen has atomic mass of 1 gram, and oxygen has atomic mass 16 grams in terms of quantitative analysis of elements. In reality, it is not taken as grams but considered as unified mass. It is always observed in the formula of water that 1 oxygen atom always combined with 2 atoms of hydrogen. And if we consider the unified mass of 1 oxygen atom, it is roughly measured as 16 gram. This 16 grams will combine with 2 grams of hydrogen. Taking the ratio of both the elements in this water formula, it will always show 16:2, or in simplest ratio, that is 8:1. Whichever sample of water, be it a seawater or any fresh water source, this ratio remains constant. Hence, it supports law of constant proportions. Now let's do some practice. What is the ratio of calcium, oxygen, and carbon in calcium carbonate? Calcium carbonate, according to the law of constant proportion. Here we will make a table with 3 columns and 2 rows. The first row shows number of atoms in the formula. The second row shows the atomic masses of the elements in the formula. Since there are 3 elements in the formula given in the questions, each column is dedicated to 1 element. The first is calcium abbreviated as Ca, the second is carbon abbreviated as C, and the third is oxygen abbreviated as O. From the formula, there is only 1 atom of calcium, 1 atom of carbon, but 3 atoms of oxygen. Atomic masses of calcium, carbon, and oxygen are 40, 12, and 16 respectively. Now if we make the ratio of all 3 elements, it will come out as 40:12:48. Multiply 3 with 16 to get atomic mass of 3 oxygen. In the simplest ratio, it is 10:3:12. This is part 1 of Atoms and Molecules. Law of multiple proportions will be taught in higher classes. I hope you like this video. For further topics, stay tuned to my channel. Keep learning, keep exploring.